Welcome back to another episode of ColaVision. Let me see if I can just play this camera a little bit. Yeah, look good. Should have done this before the video started. All right. Hopefully you can read this. This is an example of what's known as a perfect elastic collision. So we've got a perfect elastic collision. Two things hitting each other in a head-on collision here. Anyway, let's kind of get into this a little bit. Now, we already know what to do when you've got two objects that hit and kind of bounce off each other. So that's what this problem is. This problem, there's a 2-gram particle. Let's see if we can do this. We got a 2-gram particle moving at 5.4 meters per second, and it makes a perfect elastic collision with a resting 1-gram object. So let's kind of draw this out maybe a little bit. So we've got, here we go. We've got a 2-gram object moving at 5.4, and it's going to run into a 1-gram object, and it's just sitting there, so it's not even moving. So the first equation pops in your head. These two things are going to hit and bounce off of each other. Well, the first thing that should pop in your head is M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final is what we've got. So, and that is our first equation. There's just, there's only one thing here though. We can go ahead and do something. If I make this M1 over here, and I make this one M2, well, M2 is just sitting there, which means V2 initial is 0, so I can go ahead, and I can just go ahead and make that one 0. I can go ahead and get rid of that. So M2 V2 initial, that cancels out 0. That's what this problem did to make it easier. Most of these problems usually have this object coming back in this direction. And if you have this object moving backwards like this, you got to make sure you give it a negative velocity for your V2I. But this one's supposed to be easier since that's sitting still. Now, what this problem wants you to do is find the speed of these two particles after they hit. As of this time, you cannot do this problem. What's going on is this. We have to have a special helper equation. How about we call it that? The helper equation. Because go ahead and look, try and put in your numbers. We've got a 2 moving at 5.4 equals, well, we've got the same 2, V1 final, plus 1, V2 final. How can we find V1 or V2? Well, we're kind of in a pickle here. Well, we can do one thing. 2 times 5.4 would be 10.8. So this is 10.8 equals 2 V1F plus really V2F. There's no sense writing that 1 down there. Anyway, so how do you work a problem where there's a hit and bounce and there is no final velocity? See what happens? The easy problems would have given you one of these two speeds. But this one did not give you either one. Hey, don't get to worrying. We've got a way out. You need a second equation. This equation is derived from conservation of energy. This equation looks like this. V1 initial plus V1 final equals V2 initial plus V2 final. This equation is derived from the fact that kinetic energy, 1/2 mv squared, it's derived from the fact that kinetic energy is not, there is no kinetic energy lost in a perfect elastic collision where two things hit and bounce and no energy is lost. That's where this is derived from. I can make a second video on that if you want to know how to derive this equation. This is your go-to equation. If you ever work a problem where two things hit and bounce off each other and it doesn't give you a final velocity, you need this equation. So what I'm going to do is I'm going to use this equation to help me with this problem. Because you see, take a look. I'm going to write that equation out again. V1 initial plus V1 final equals V2 initial plus V2 final. It's an easy equation to memorize. Let's take a look. We already know that V2 initial is 0. We know V1 initial was 5.4, so look at this. 5.4 plus V1 final equals V2 final. All you've got to remember is this. If you've got two unknowns, you've got to have two equations. So to work a hit and bounce problem without a final velocity, you need your mv equation, plus you need this 1v equation. And that's it. Now all we've got to do is substitute. So all I'm going to do is take this V2 final. Look, it's already equal to V2 final. That's awesome. So it's already given us this V2 final. And all we got to do is plug it in right there for that V2. And by the way, I didn't say it, but somebody probably watched this video and was like, why didn't you do anything with grams? Why did you leave that in grams? Y'all, an MV equation is nothing more than a glorified proportion mathematically. That's why if you take a look, all the units cancel out for the M, so that's why it was really irrelevant in the first place. So, not a big deal. The units cancel out. So I'm going to take this and I'm going to plug it back into this equation. So I'm going to have 10.8 equals 2 V1F, and in place of V2F, so I'm going to have plus 5.4 plus V1F. And now all I got to do is look, now I've only got one unknown. So I'm going to subtract 5.4 from the other side, which that's going to leave me with 5.4. 2-1V, I've got 2 V1F and a V1F, which is going to make 3 V1F. So now to finish this problem, all I've got to do is 5.4 divided by 3, 1.8. And it's positive, and that is important. Positive 1.8 meters per second. So there's V1F. And now if I want to know V2F, well, I can go right here and plug it in. 5.4 plus 1.8 equals V2F. And sure enough, you plug this together and you get 7.2 meters per second. And now if you take a look, the answer is on here. 1.8, bam, and 7.2. We got both answers. Y'all, that's the only trick. Let's run through it one more time. I mean, that's 7 minutes. You can stop now if you don't want to see anything else. But, I mean, why would you give up now? You're doing so good. Typical problem. Hit and bounce. Here, try this one on your own. Here comes one object. Let's have this object coming at it. We're going to crash into each other. Let's give this one a mass of, what do you want to say? Let's give this one a mass of 5 kilograms. Again, the units didn't matter. It could have been 4 kilograms. Oh, speaking of which, let's do 4 kilograms. So we've got 5 and a 4 in a head-on collision here. Let's give this one a velocity of, it's moving to the right, so it's going to be positive 2, because I want the numbers to be very easy, meters per second. Let's give this one a velocity of, I'm about to do something crazy, negative 4 meters per second. So it's a little bit lighter, but it's moving twice as fast, which means it should win this battle. All I need is 2 equations. Hit and bounce. You tell me what happens after these two hit. What is each of their final velocities after they hit? You need 2 equations. You need your M1 V1 initial plus M2 V2 initial equals M1 V1 final plus, it's a lot of writing, I know. We need this equation, and we need, and anytime you see this, hit and bounce, no final velocity, we need this equation. V1 initial plus V1 final, I almost messed up myself, didn't I? Equals V2 initial plus V2 final. All we got to do is plug in numbers into this. Literally, that's it. So we're going to have, this is going to be my M1. This one's going to be my M2. So my M1, my M2. So my M1 is going to be 5 times 2. So we're going to have 5 times 2 plus 4 times negative 4 equals 5 V1F plus 4 V2F. Now let's go ahead and plug in numbers over here too. V1 initial was 2 plus V1 final. V2 initial is negative 4. Y'all, the physics is long over in this problem. Really, the physics ended when you wrote these two equations. When you recognize hit and bounce, this was over. So this is going to be 5 times 2, 10, 4 times negative 4, minus 16. And then let's see, 10 minus 16, so this is negative 6 equals 5 V1F plus 4 V2F. You just got to keep all these V1s and V2s straight here. Over here, for some reason I always solve for V2F when I do these problems. I always solve for that one. I don't know why I'd never solve for V1F. It's just, I don't. So I'm going to add that 4 to both sides. So I'm going to end up with 6 plus V1F equals V2F. And just like I did in the other example, I'm going to plug that in for V2F. Now the only thing, make sure you distribute this time because I've got a 4 in front of this V2F. So it's going to be 4 times this. So in other words, I'm going to have plus 4 and then 6 V1F in there. So let's see, that's 5 V1F. Boy, you can tell I got a little dyslexia. I just did this whole problem backwards. Anyway, negative 6 equals 5 V1F. 4 times 6, distribute this. 24 plus 4 V1F. Combine like terms. Subtract 24 from both sides. We end up with negative 30. I think you can tell that something's going to be going this way after this. Negative 30 and equals 9 V1F. So we've got negative 30 divided by 9, 3.333333. So this should be negative 3.33, which means if V1F is negative 3.3, that means after this collision, this one over here is going to actually knock this guy backwards. So he's going to slap, get out of here. And the reason why is he's traveling so much faster. So what's going to happen to his speed? Is he going to end up getting bounced back the opposite direction, or will he just keep coming in the same direction but maybe a little slower? We can find out. All we got to do is plug it in right here. So this would be 6 plus negative 3.33. Well, that's not too bad. This is going to end up being 2. Check this out. 2.67 meters per second. And notice something. We got two answers. First one's negative. This one's positive 2.67. It means after these run into each other, this one's going to hit and bounce backwards. And oddly enough, this one's also going to hit and bounce backwards. But anyway, don't get scared if you see a hit and bounce problem with no final velocity. It just means mv, 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 mv. You got to do your big mv equation. And then all you got to do is chase that with V1 initial plus V1 final equals V2 initial, V2 final. And you'll solve. I always end up solving for V2 and then plug it back into the other equation. And that's it. While it looks like a really hard problem, isn't that bad. But anyway, thank you for watching the Old Turdford channel. Bye now.